Hi everyone, it's Shivali from 1301, and today we're going to be going over special methods in object-oriented programming. So special methods are just methods for which Python has already implemented a default implementation, but if you write your own implementation of it, Python will use what you wrote instead of the default version. So special methods are sometimes called magic methods or double underscore methods, and this is because special methods are written with two underscores and then the function name and then the parameters in parentheses like a regular function. So some special methods that you're probably already really familiar with are the init method or the string method. So today we're going to go over these two plus lots more, and we're going to do this by coding a class GT student, giving it some attributes, and then looking at how the special methods work. So first we're just going to start out with our function header and the init method. So I've given the GT student class different attributes such as name, GTID, major, GPA, and year. So if we run this, and I'm just going to start a new shell. So if we run this and I create a new GT student object, and I give it a name, a GTID, a major, a GPA, and a year. If I just print out this object, or just call the object, it doesn't really give me anything very useful. It just tells me that this is a GT student object at, and then it gives me the memory location in hexadecimal, which tells me not much about the object except for that it's of class GT student. So what Python lets you do instead is there's a special method called the stir or string method, and it takes in self, which is the object itself, and you can just have a string that you define, and that's what Python will return whenever you print out an object. So we could create a string that's a little bit more useful and informative, and Python will print that out when we print out the object. So maybe we want to say the name is a, and then the major student, and then maybe we just want the GPA and then the year and the GTID. So the string doesn't have to be really complicated, just something that shows you all the different attributes of the object. So we'll just do dot format, and then we'll fill in the name, the major, the GPA, the year, and the GTID. So now if I run this and I have the same object Shivali, but if I print Shivali, it's going to give me the string that I defined in the string class. So this is a lot more informative than what we had before of just having a GT student object at a different memory location. So it's always really important to have a string method when you write a class. So another special method that's very useful to implement is the equals method. So the equals method just allows you to compare two objects and see if they're equal. So suppose I made another object called Shivali2, and I gave it the same exact attributes as the object Shivali. But right now, if I compare Shivali and Shivali2, I get false, even though they're representing the same person. This is because Python uses the different memory locations of the objects to compare objects if we haven't defined our own equals method. So in this, when I say Shivali equals Shivali2, it looks at the memory location for Shivali and it says, is this equal to the memory location for Shivali2? And since they're two separate objects, they're stored in different memory locations in our computers, and Python gives us false. So what we can do is define an equals method, so it's just two underscores and then EQ. And when you're writing special methods, make sure that syntactically you're following the two underscores, and then the function name needs to be exactly how Python's default implementation method is spelled. So if I use, for example, I spelled out the word equals. If I wrote a method like this, Python would not use this instead of Python's EQ method, since it doesn't recognize that this is the same method as EQ, so it has to be coded exactly the same way. So the equals method takes in two objects, usually self, the object that the equals method is called on, and other. And we just want to return a comparison of all the different attributes between the two objects. So we want self.name to be equal to other.name, and we would want self.gtid to be equal to other.gtid. And we'd want their majors to be equal to each other, and we'd want their GPAs to be equal, and then we'd also want their years to be equal. So usually for two objects to be equal, all of their attributes have to be equal. So now if we run this and we have the Shivali2 object and Shivali, we check if they're equal, Python gives us true, because now it uses the equals method that we've written instead of the default implementation. So another method we could have is the not equals method, which is NE, and that also takes in two objects, self and other. And this time we just want to compare all the different attributes and just see if even one of them is not equal to the other one. So we'd want to see if self.name is not equal to other.name, or maybe they have the same names, but their GTIDs are different, which means that they would not be equal. Or maybe the name and the GTIDs are the same, but even if the majors are different, they would not be equal to each other. And then we would do the same thing for GPA, and the same thing for the year. So we want the not equals method to return true if the two objects are not equal to each other, and false if they are equal. So now maybe we have Shivali, and maybe we make another object called Damien, and we give that object the GTID, the major, the GPA, and year. So we can clearly see that these two objects are not equal to each other. They're representing different GT students. So now if I say Shivali not equal to Damien, we'll get true because Python will use our not equals method that we've just defined. Another way of doing this is if you already have an equals method implemented, the not equals method should just return the opposite of the equals method. So for example, if the equals method returns true, that the objects are equal, then the not equals method should return false, since checking if the objects are not equal, they aren't. So that should return false. So you could also just return the opposite of the equals method. And if we run that, that will also give us true, because Shivali is not equal to Damien. So those are two ways of doing it, but the way we did the second one, where it says return not self equals other, that only works if you have a correctly implemented equals method inside your class. So some other ways, or some other magic methods that we're going to look at are the less than, which is underscore LT. And that also takes in two objects, self and other. So this is looking at, is self less than other? So if self is less than other, you would return true. But if self is greater than other, you'd want to return false, since that means self is not less than other. So there's lots of different ways of implementing this. The way I'm going to implement it is by comparing their GPAs. So I'll say self is less than other if the GPA of self is less than the other's GPA. So I'll return self.gpa less than other dot GPA. So if I run that, and I have Shivali, and then suppose we have Damien, who also has the same GPA. If I do Shivali less than Damien, it gives me false since the GPAs are not, since the GPA of Shivali, which would be the self, is not less than the GPA of Damien. But we can also compare multiple things in our less than method. So maybe we want to first compare the GPAs, but if the GPAs are the same, maybe the way we want to see if an object is less than another is by looking at the year of the objects. So maybe we have if self.GPA is less than other.GPA, you would return true. Else, maybe you'd want to compare the years. So you can define your less than method, however is useful for the implementation of your class. So maybe we have Shivali, and then we also have Damien. So now if we say Shivali is less than Damien, well, it still returns false, but it first compared their GPAs, and then it compared the years. So now we're going to move on to the less than or equal to method, which is just underscore underscore LE. So in this one, maybe we want to say that an object is less than or equal to another if the GPA is less than or equal to the other's GPA. So you just say return self.GPA less than or equal to other.GPA. And notice over here when we use the less than or equal to, since the GPAs are integers or floats, Python automatically knows how to compare integers or floats because they have built-in less than or equal to, greater than, and greater than or equal to, and equals built-in methods for those data types. So now if I say Shivali and Damien, if I say Shivali less than or equal to Damien, Python gives me true because when it ran this, it looked at the less than or equal to function that I have defined in my class, and it said is self.GPA, which is a 4.0, less than or equal to other.GPA, and a 4.0 is less than or equal to a 4.0, so return true. So another special method we have is greater than, which is just GT, and that also takes in two objects. And this one would basically return the opposite of the less than. So maybe we say return self.GPA is greater than other.GPA. So now we have Shivali and we have Damien, and maybe Damien now has a 3.9. If I say Shivali greater than Damien, it returns true, since self.GPA, which is a 4.0, is greater than other.GPA, which is a 3.9. So if we didn't have these implementations defined in our class, Python would just use the memory locations and compare based on memory location. So the next one we have is greater than or equal to. So suppose before we even coded this, we tried saying Shivali greater than or equal to Damien, and this returned true, but that's usually based off the memory location. So we can define our own greater than or equal to, so it's just GE. That also takes in self and other. Maybe we just want to return self.GPA greater than or equal to other.GPA. So now we'll compare based off of GPAs. And if we do this comparison, we'll get true since 4.0 is greater than or equal to 3.9. And we don't have to compare based off of GPAs. We could have even compared based off of the name. So if we do self.name greater than or equal to other.name, suppose this time, okay, let's run that again. We have Damien, Shivali, and then we say Damien is greater than or equal to Shivali. we get false. So it takes self.name, and this time self is Damien, since that was the first object. And it's always good to keep in mind which object is self and which one's other, because it changes what the function returns. So self in this case is Damien, and the name of Damien is just Damien. So this returns, is the string Damien greater than or equal to the string of Shivali? And in this case, Python returns false. So I hope this video has given you a good review of what the different special methods are and why they're useful. Thanks for watching.